Okay, good morning class. Welcome to this lesson on Kinematics 14, projectile example number 2. Today we will be able to solve the following projectile motion problem for time, how far, and how long. So this is a classic problem where we have a projectile being fired. I'm going to say it's going to be fired out of a cannon. Okay? Projectile's going to be fired out of a cannon, and it's going to hit some object over here. Okay? We are going to say that the level it hits is the same level as the cannon. So there is no change in height from the cannon, okay? So it's on a straight line. Whatever it hits is at the same height as the cannon. We're going to say this fires off at 25 meters per second, and we're going to say it fires at an angle of 35 degrees. So how long was it in the air? How high did it go up? And how far did it go? So the first thing we need to solve for is we need to break this down into its components. That is essential for pretty much any projectile motion problem. Okay, so this side, this is going to be the velocity initial in the y direction. This is going to be equal to the sine of 35 times 25 meters per second. Okay, you should be getting used to this now and how I'm solving this. Okay. So that's equal to that. So this is going to be equal to 14.3 meters per second, and this one is going to be equal to the cosine of 35 times 25 meters per second, and so this is going to end up coming out to be 25, excuse me, not 25, 20.5 meters per second. Okay, so we have our initial velocity in the y, we have our initial velocity in the x. Our initial velocity total is 25. How high does it go? How long is it in the air? And how far does it go? So the question becomes, what equation do we use? Well, when I look at a very classic projectile motion problem where it forms this parabolic shape here, my problem-solving tip to you is to divide it in half. The first half being from the launch till it reaches the top of the path. This is the top of the path. And the second half from the top of the path to the landing. Okay, so we go from launch, top to bottom. We could go all the way, but if we use our equations, what you're going to end up seeing is that we might need to solve for a quadratic, and while people can do that, it's not like it's impossible. I find this to be a simpler way of breaking things down, because this also can help you in future problems. So I think this is a good problem-solving strategy. So, if you notice, the time it is in the air, is limited by the y direction. Okay, gravity is pulling this thing back down. Gravity is what causes this thing to come back to the ground. So the time in the air is limited by the y direction. So let's look at the y direction first. We have our initial velocity in the y direction is equal to 14.3 meters per second. Our final velocity in the y direction is going to be equal to 0 meters per second, because in the y direction, at the top of the path, the velocity is equal to 0. We know our acceleration is negative 9.8 meters per second squared, and we want to solve for time. Okay, when I write it that way, there's only one way to solve this, really, and that is our final velocity is going to be equal to 0. Excuse me, it's going to be v final equals v initial plus at equals 14.3 meters per second plus negative 9.8 meters per second squared times t. If we solve for t here, we subtract 14.3, divide by negative 9.8, we get a time equal to 1.45 seconds. So it takes 1.45 seconds for this projectile, this cannonball, to reach the very top of its path. Well, that's good, but we want to know the whole path, and since both sides of the path are equal, there is no air resistance. We're calling this projectile motion, free fall basically. So our time is going to be equal to 1.45 times 2, because it's going to take 1.45 to get up, 1.45 to get back down. So 1.45 times 2 is equal to 2.9 seconds total. Okay, 2.9 seconds total. Okay, so so far we solved for time. Okay, by splitting it up into two. Now, my next question is, how high did it go? Okay, so I'm going to draw this out again real quick. cannon 25 meters per second. The velocity in the y direction is equal to 14.3 meters per second. Okay, so our next thing is to solve for how high does it go? Well, this point right here, this middle point, which we determined earlier, that's the highest possible point. So at the highest possible point, once again, the final velocity is equal to 0 meters per second. The initial velocity is equal to 14.3 meters per second. The acceleration is equal to negative 9.8 meters per second squared. The time it's in the air to reach this highest point is 1.45 seconds. And so what is our delta y? What is our height? Well, our delta y is going to be, so if we use these variables right here, I would go with this equation, b squared equals v naught squared plus 2a delta y. I'm putting y in. Okay, so our final velocity is going to be equal to 0. Our initial velocity is going to be 14.3 meters per second squared. Okay, plus 2, negative 9.8 meters per second squared times delta y. Okay, so when we solve all this out, we get a delta y of equal to 10.4 meters. So 10.4 meters is how high it was in the air. And notice, once again, that because I originally split up my projectile motion path into two parts and I was looking at the top of the path, I already had the time it was in the air to the top of the path. Okay, so that's that. Our last piece is how far does this thing go? And this thing goes, well, we know in the x direction, let's go look back here, in the x direction is going 20.5 meters per second. So the velocity, the initial velocity in the x is equal to 20.5 meters per second. We are solving for delta x, and we know this thing is in the air for a total time of 2.9 seconds. So our velocity in the x equals delta x over t, or 20.5 meters per second equals delta x over 2.9. When I multiply 20.5 by 2.9, we get 59.5 meters. So that is the answer for how long, how far, and how high this projectile was in the air.